All right, last section of the year. So we're looking at inverse matrices. If we have two matrices that are inverses, when we multiply them, we'll get the identity matrix. This is what the identity matrix looks like. And it can be any size as long as there are ones along that diagonal and all the rest are zeros. So there's two things we're going to look at in this section. One, they'll give you two matrices and ask if they're inverses of each other. So we'll check it by multiplying to see if we get this answer. And then the other is finding the inverse, and I'll show you that on the next slide. All right, so here's the first example. We're going to check to see if two matrices are inverses of each other. So again, in order to figure that out, we need to multiply them. So this is a good review of multiplying matrices. What should I be circling on the first matrix? Yes, the rows on this one. And what over here? The columns here. So we're going to multiply. And there are fractions. All right, so 3 times 3/4 is 9/4, right? Should be able to do this in our heads. 3 over 1. 3 times 3, 4 times 1. So we've got 9/4 plus what? Negative 5/4. Negative 5 over 1 times 1/4. Okay, so that's your first term. We're just going to show our work on this. Okay, what if I wanted the number right below that? What am I going to add together? Negative 2 times 3/4. Negative 6/4. And then 6 times 1/4. 6/4. Okay. This one right here in the upper right. What am I adding together? (15/8). So I'm taking 3 times 5/8. And then negative 5 times negative 3/8. Negative 15/8. And what about this bottom one? Plus? All right, so let's simplify this. If I have 9/4 and I add it to negative 5/4, what do I have? You have 4/4, right? Which is 1. What about right here? What about here? And this one? 8 over 8, which is 1. Is that the identity matrix? So yes. You're just multiplying those two matrices. Good question. If this was a negative one, it would be no. It has to be identical to the identity matrix, which is just positive ones on the diagonal. If they were all negative ones, it would not be the identity matrix. It has to be just like this. Other questions? All right, so here's how you find the inverse of a matrix. So we'll write this down. So if your matrix is A, B, C, D, here's how we find the inverse. We're going to take 1 divided by AD minus BC. What does AD minus BC remind you of? A times D minus B times C. That is the determinant. Okay, that's why we learned that in the previous section. Now what happens if we get a 0 for the determinant? Which we did a few times in our homework. We'll be doing 1 divided by 0, right? Which means what? What happens when we divide by 0? It's undefined, so there is no inverse for that matrix. If you ever get a 0 for the determinant, then there's no inverse at all. So we're going to take whatever this is, 1 times this number down here, or 1 divided by that number, and then we're going to take that and multiply it by all of these terms. Now look at what we did. We switched the position of these two numbers, and then what did we do to the other two numbers? We just made them negative. We didn't move them at all. We just changed their sign. So we'll try this twice. So if we're going to look for the inverse of this matrix, 6, 2, negative 3, 1, we need to do 1 divided by the determinant first. 1 over, now let's figure out what the determinant is. It's going to be 6 minus 6 minus negative 6, which is 12. Okay, so the determinant is 12. So 1/12 is your number on the outside. And we're going to multiply it so we need to switch the A and the D to the opposite spots. So now this is 1 and this is 6. And then what do we do to the other two? We just switch the sign. So now this is positive 3 and this is negative 2. And now we just take them all by 1/12, multiply them by 1/12. So we've got 1 times 1/12, which is 1/12. If we take 1/12 times negative 2, let's simplify it. What would it be? Negative 1/6, because it's 2 over 12, which is 1/6. What about 3 over 12? And 6 over 12. So that is your inverse. If you multiplied this by this, you would get the identity matrix. 1 left, and then we'll get to the homework. So I'm going to give you guys a 60-second head start. See if we can end up with the same one. Follow the exact same steps. What happened? Any questions?